Hey, this is a video on compound interest. So we talked about simple interest and we saw some graphs of it and we saw that it was a linear relation. So compound interest is different. So with this type of interest, you earn interest on your interest, not just on your initial investment. So your interest that you make goes back in and gets added to your initial investment. So then when you earn interest on that, it's a bigger amount. So you get more interest every time. So just for example, let's say you invested $100 and it was at a rate of 10%. Well, after you invest that money, 10% of 100 would be $10. So you would get $10 in interest. Then they would put that back into your principal. So now instead of just having $100 to invest, you would have $110. And then you would earn 10% on that. So 10% of $110 would be $11. And then you add that back on. So $110 plus $11. Would be $121. And then let's say you earn more interest. So now you earn another 10%. So that means you earn $12. And then when you add that back on, you're getting $132. Or $33, sorry. So you can see that the amount of interest that you make, it was first you just made $10, then you made 11, then you made 12. So it's going up and up and up. So if you were to graph this kind of an interest, just a rough sketch, starting with your initial investment, if you earn like 10, then 11, then 12, oh, it's just making a straight line for me. Your interest is going to start looking like this. So it's going to increase faster and faster and faster. So it won't be linear. And I chose a small number, so like maybe that was a bad example. Let's make it a little bit bigger and see what happens. So let's say we have $1,000 that we're going to invest at a rate of 10%. Okay, so our interest would make us $100 this time. So when we add that back in, we'd have $1,100. And then our interest on that would be $110. And then we add that back in and we'd have $1,210. Then we earn 10% on that. So now we'd have 121, which would give us 1,331. So you can see that like 100, 110, 121, it's going to start going up and up and up, faster and faster and faster. Okay. So let's look at a way to calculate that. So let's use our $1,000. So let's say we are investing $1,000 and we're earning 10% every year. So 1,000 is our principal investment and our rate is 10%. Or we could write that as 0.10. So we can see after 1 year, we will have that. After year 2, we will get that. After year 3, we will get that. And let's just do a couple more years. Sorry, I'm going to keep this green thing going. After year 4 and year 5. Let's just see what those would look like. Okay, so we're at 1,331 times 10% would be, so the interest on that would be $133.10. giving us a total of $1464.10, and then our interest on that would be $146.41. So then in year 5, we would end up with $1,610.51. Okay, so we started with an initial investment of $1,000, and after 5 years, we have $1,600. So it's kind of annoying to calculate compound interest like this, right? Like you have to calculate each year. Like what if you wanted to invest $1,000 for like 20 years? You'd have to do this till you get to 20 years, and that would take forever. So let's look at using a formula to help us. So basically what we're doing every time, just to sum it up for you, basically what we're doing is we're taking our $1,000 and we're multiplying it by 10%. Let's write that as 0.10 to figure out our interest rate. And then we're adding our $1,000 back on. You know, so we're finding the interest, how much interest we'll make. So $1,000 times 10% is $100. And then we're adding back our principal to figure out how much we've made on our investment. So this is kind of the formula we're using. So a way to tackle this, instead of like adding the 1,000 back on, is instead of multiplying 1,000 by 0.10, we're going to actually take our principal amount and we're going to multiply it by 1.10. And what that does is it kind of adds back in that one, kind of adds back in the $1,000 that we wanted to. It adds our principal back in. So try it out. So $1,000 times 1.10 will equal exactly what we had in our first year, $1,100. 1,100 versus if we did it this way, we would get 100 plus 1,000 equals 1,100. So we can just do it quicker, multiplying it by 1.10. And then if we want to do it for, say, 5 years, what ends up happening is we're just like multiplying it out 5 times. So that repeated multiplication is also known as an exponent. So it turns out, if we wanted to, we could do 1,000 times 1.10 to the power of 5 to get the amount of interest that we'll earn in 5 years. So if we do 1,000 times 1.10 to the power of 5, that will equal 1,610.51. That number right there is the same as our year 5 investment. So it turns out that compound interest is actually exponential, which you'll learn a lot more about in grade 11 math. So this is just an introduction, so you don't really need to know this much detail, but that's how you could calculate compound interest if you wanted to. And there's actually a formula. And the formula is, I don't know, people write it all different ways. But one way to write it would be like future value equals present value times 1 plus your interest rate to the power of n. And you could see different variables. So this means like your future value. So what's the amount you're going to have at the end of your investment? This is like your principal, or they call it present value. How much do you have when you're starting? So like your $1,000 investment. That's your interest rate. As a decimal. And this is your, we used T in the last one. So you could also use T, but this represents the number of periods. So compound interest gets a little bit more tricky than simple interest. And it turns out that investments can compound differently. So they could actually compound like twice a year or 4 times a year. And that just means like how many times is your interest going to get calculated and put back into your principal. So the more times it compounds, the better, because you're going to earn more interest. So that's a little tricky. So let's just say you had an investment. So let's say you wanted to invest $2,000. That's your initial investment. So we're calling that present value, or we could call it just the principal. And let's say our rate is going to be 6%. So we're going to earn 6% interest. So instead of earning 6%, we could just write 0.06. And let's say it's compounding once per year. So the compound period is once per year. Or every year. So let's say we want to figure out how much our investment will be worth after 10 years. So N would be 10 because there would be 10 compounding periods. So if it compounded twice a year, so let's say instead of once a year, it was going to be twice a year. In 10 years, it would actually compound 20 times, which would just mean like, after 6 months go by, it would check, oh, let's dump your interest in. And then after another 6 months, it would be like, ooh, let's add some interest. Okay, so let's try this formula out. So future value, or sometimes you might see like an A just for amount, equals. So your present value or your principal is $2,000. 1 plus 0.06. And then you have 10 compounding periods, so to the power of 10. So just to simplify this, we have 2,000 times 1.06 to the power of 10. Okay, so let's calculate that. We need a calculator. 1.06 to the power of 10. And then I'm going to multiply that by 2,000. And the amount I get is $3,581, and I'm going to round it up to 70 cents. So that's the amount of money on my $2,000 investment. After 10 years, I'm going to have $3,581.70. So if you subtract 2,000 from that, you've made $1,500 in interest, really. And that's how you calculate compound interest. Now we can rearrange it, and if we ever wanted to, you can always rearrange equations. So maybe instead of trying to figure out the future value, we want to know how much our initial investment was. So you can always rearrange equations. I feel like I don't love FV and PV. It's weird having two variables. I mean, you can, no big deal. I'm going to change it to A and P for amount, your future amount and your present value or your principal. I feel like I like those better. Okay, so say we had A equals P times 1 plus R to the power of N. Let's say we wanted to rearrange it for P. So what we could do is divide both sides by 1 plus R to the power of N. Those would cancel out because they would just divide by each other and equal 1. So I would just leave P equals A over 1 plus R to the power of N. So if you knew the future value, so if you knew somebody made $12,000 in the future and you knew what their interest rate and their time period was, you could actually calculate their initial investment if you wanted to. So you can always rearrange formulas. So that's compound interest, this crazy formula, which you actually don't need to know in grade 9. It's more of a grade 11 concept. But it's good to just understand what compound interest is, which is basically earning more interest because the interest that you earn is getting added back onto your principal. And the same rules apply. So like the longer the time period, the more money you're going to get. The bigger the interest rate, the more money you're going to get. And this might be a confusing topic, but the number of times it compounds, the more times it compounds, the better. Because that just means they're going to add your interest back into your principal more often, which is good. Okay, that's it for compound interest.